Look up at the night sky and you will see thousands of stars scattered across the darkness. Telescopes reveal even more. Entire galaxies filled with billions of stars, planets, and clouds of gas. For a long time, scientists believed that everything in the universe was made from this visible matter. But modern astronomy has revealed a surprising and mysterious fact. Most of the universe is made of something we cannot see at all. This invisible substance is called dark matter, and it may make up most of the matter in the universe. But if we cannot see it, what exactly is it? And how do scientists know it exists? To understand dark matter, we first need to think about what normal matter is. Everything you can see around you is made of ordinary matter. Stars, planets, trees, buildings, animals, and even your own body are all built from atoms. Atoms combine to form molecules, and molecules combine to create the materials that make up the world around us. When scientists observe the universe using telescopes, they can detect this matter because it interacts with light. Stars shine, gas clouds glow, and planets reflect light from nearby stars. Because of this, astronomers can measure and study visible matter by observing how it emits or reflects light across space. However, when scientists began carefully studying the motion of galaxies, they noticed something very strange. Galaxies are enormous systems that contain billions of stars rotating around a central region. According to the laws of gravity, the speed at which stars move around a galaxy should depend on the amount of mass inside that galaxy. In simple terms, if there is not enough mass, the outer stars should move more slowly or even escape into space. But when astronomers measured the speeds of stars in many galaxies, they discovered that the stars were moving much faster than expected. The visible matter inside those galaxies simply was not enough to create the gravitational pull needed to hold them together. This observation led scientists to an important conclusion. There must be a large amount of invisible matter creating extra gravity inside galaxies. This unseen mass does not emit light, does not reflect light, and cannot be detected directly with telescopes. Because it cannot be seen, scientists began calling it dark matter. Another powerful clue appeared when astronomers studied how galaxies interact with each other. Sometimes galaxies pass near one another, and their gravity causes them to bend and stretch slightly. By measuring these gravitational effects, scientists can estimate how much mass the galaxies contain. Once again, the calculations revealed far more mass than could be explained by visible matter alone. Something invisible was clearly contributing additional gravity. Dark matter does not behave like ordinary matter in many ways. It does not interact with light, which is why it remains invisible. It also does not seem to interact strongly with atoms or molecules. Instead, its presence is detected mainly through its gravitational effects, the way it pulls on stars, galaxies, and even light itself. Today, scientists believe that dark matter may make up about 85% of all the matter in the universe. This means that everything we can see, every star, every planet, every galaxy, is only a small fraction of what actually exists. The rest is hidden in a mysterious form that scientists are still trying to understand. Even though dark matter cannot be seen directly, its influence is everywhere across the universe. It helps shape galaxies, controls how they move, and may have played a major role in how the universe formed in the first place. Because of this, understanding dark matter has become one of the most important challenges in modern science. To better understand dark matter, scientists began looking for more evidence that this invisible substance truly exists. One of the strongest clues came from studying how galaxies form and stay together over long periods of time. When astronomers use powerful telescopes to observe galaxies, they notice that stars move in stable patterns around the center of each galaxy. These stars should normally be influenced by the gravity of all the matter inside the galaxy. However, when scientists calculate the total gravity created by the visible stars, gas, and dust, it is still not enough to explain the movements they observe. The galaxies should slowly fall apart or lose their outer stars over time, but they do not. Instead, they remain stable for billions of years. The best explanation scientists have found is that galaxies are surrounded by enormous halos of dark matter that create additional gravity, holding everything together. Another important discovery came from a phenomenon known as gravitational lensing. According to the laws of gravity, massive objects can bend the path of light as it travels through space. This means that when light from a distant galaxy passes near another massive object, such as a cluster of galaxies, the light can bend slightly before reaching Earth. Astronomers can observe this effect through telescopes and measure how much the light has been bent. When scientists perform these measurements, they often find that the bending is much stronger than expected based on visible matter alone. In other words, there must be far more mass present than what can actually be seen. Once again, dark matter provides a convincing explanation because its gravity could create the additional bending of light that scientists observe. Even though dark matter cannot be seen directly, researchers have developed several ideas about what it might be made of. One possibility is that dark matter consists of unknown types of particles that do not interact with light the way ordinary matter does. These particles would pass through space, and even through planets and stars, without being noticed, except for the gravitational pull they create. Scientists around the world are building special detectors deep underground to try to capture evidence of these particles. These detectors are designed to be extremely sensitive, allowing researchers to notice even the smallest interactions between dark matter particles and ordinary matter. There are also large scientific experiments taking place in powerful particle accelerators. In these facilities, scientists collide particles at very high speeds to recreate conditions similar to those that existed shortly after the universe formed. By studying the results of these collisions, researchers hope to discover new particles that could help explain the nature of dark matter. Understanding dark matter is extremely important because it may help answer many bigger questions about the universe. For example, scientists believe dark matter played a crucial role in the formation of galaxies billions of years ago. The gravitational pull from dark matter may have helped gather clouds of gas and dust together, eventually leading to the creation of stars and galaxies. Without dark matter, the universe might look very different from what we observe today. Despite decades of research, dark matter remains one of the greatest mysteries in modern physics. Scientists know it must exist because its gravitational effects are clearly visible across the universe, but they still do not fully understand what it actually is. This mystery continues to inspire new experiments, new technologies, and new ideas as researchers search for answers hidden in the darkness of space. Even though scientists cannot see dark matter directly, modern technology has allowed them to study its effects across the universe in greater detail than ever before. Large observatories and space telescopes now collect enormous amounts of data about galaxies, galaxy clusters, and the structure of the universe. When scientists analyze this data, they consistently find patterns that suggest dark matter plays a major role in shaping the large-scale structure of the cosmos. In fact, many researchers believe that dark matter acts like an invisible framework, helping galaxies form and gather together into the enormous cosmic structures we observe today. To understand this idea, imagine building a city. Before constructing houses and buildings, there must first be a foundation or structure that supports everything. In a similar way, scientists believe dark matter may act as a kind of gravitational foundation for the universe. After the Big Bang, small regions of dark matter may have started pulling nearby matter toward them through gravity. Over time, these regions grew larger and attracted gas and dust. Eventually, this material formed the first stars and galaxies. In this way, dark matter may have helped organize the universe into the vast networks of galaxies we see today. Computer simulations have helped scientists explore this possibility. By using powerful supercomputers, researchers can create models of the universe and test how galaxies would form under different conditions. When these simulations include dark matter, the results closely match what astronomers observe through telescopes. Galaxies form in clusters, large structures appear across space, and the overall distribution of matter looks very similar to the real universe. Without dark matter in these models, the simulated universe looks very different and does not match observations nearly as well. This provides additional evidence that dark matter likely plays a major role in cosmic evolution. Despite this progress, one of the biggest questions remains unanswered. What exactly is dark matter made of? Scientists have proposed several possible explanations, but none have been confirmed yet. Some theories suggest that dark matter is made of entirely new particles that have not been discovered before. Others explore more unusual possibilities, such as unknown properties of gravity itself. Because dark matter does not interact with light and rarely interacts with ordinary matter, detecting it directly is extremely difficult. However, research continues around the world. New detectors are being built to search for possible dark matter particles. Astronomers are studying galaxies and cosmic radiation for clues about how dark matter behaves. Particle physicists are running advanced experiments that could reveal entirely new types of matter. Each of these efforts brings scientists closer to solving the mystery. In simple terms, dark matter reminds us that the universe is still full of unknowns. Even though humans have learned a great deal about space, stars, and galaxies, most of the matter in the universe remains invisible and mysterious. Understanding dark matter could completely change our knowledge of physics and reveal new laws of nature that we have not yet discovered. For now, dark matter remains one of the greatest puzzles in science. But with new technology, powerful telescopes, and ongoing research, scientists continue to explore the hidden side of the universe, searching for answers to a mystery that surrounds us on the largest scales imaginable.